We stopped on the molality. I recalled the molality, and then we go dilution. And then, since we have plenty of time, we'll go through worksheets, see how we solve those problems, correct? So, let's look at this now. We defined the molarity, correct? Somebody still remembers? Somebody still remembers? What's molarity? Somebody still remembers? No? Don't let me down. Today is what? Wednesday, correct? Am I correct? It's not Monday, correct? So, molarity, what is that? Mole, okay, don't be shy. Mole over liter of the solution. The molarity, on the other hand, and we said this is the units here. This is the units, mole per liter, or capital M, or molar, correct? But this is the definition. And here the molarity is will be mole per kilogram. When I say mole of the solute, that's what is meant. And kilogram of the solvent. This is by definition. The same thing here. Mole per liter of solution. Here, kilogram, mass of the solvent. Then small m. And then here is molal. So it's very close to each other. So this is formula, as I said, I gave you in the PowerPoints, all those formulas, and I would recommend highly that you print this out for the open book quiz and exam. Okay, guys? Can I take this one out? Okay, let's take it out and just refer to the PowerPoint to remind ourselves what we have so far covered. Yes, this slide here is very important because it really covers all the most important formulas we need for this chapter. This is really the heart and core of the chapter itself, correct? So, but this is only is said, but it's difficult to be really realized because you have to review a lot of calculations in order to understand the whole concept. We did in the lab do a lot of stuff, calculations of molarity and all the stuff, but it's sometimes very hard to connect between both of those. So the last thing here before we go further, there is another formula we have to look into, which is called dilution or dilution law. Dilution law is C multiplied by V. This is concentration of the concentrated solution. This is its volume equal to C diluted concentration multiplied by V, its volume. And sometimes V is the total. After adding is sometimes the total. But anyway, some textbooks, they don't like this formula with the C. They put M as a molarity. So molarity, this is concentrated volume of the concentrated. This is, whoops, sorry. And molarity of diluted Okay, so it depends what book you are reading, but they mean the same thing. So sometimes the concentrated, not the diluted one, it has a name here. It has a name called stack solution, pure stack solution, stack. So it's the original one. This is what means original, not diluted, nothing happened, clean and in a very good condition, this solution. So it's called stuck solution, and the concentration is this will be the highest of it. So that's stuck solution. So this is called dilution law, or sometimes just referred as formula. So you can, if your coffee is bitter, what you will do, you add to it what? Tabor, correct? Hot tabor to make it more diluted, so it will be the bitterness will be out. Or you add to it too much of milk, which is still like tabor, the volume will increase, so it's the concentration of the caffeine will be the least, will be decreasing. So the solution will be what? Will be diluted. So the coffee will be diluted by adding extra hot tabor or milk, correct? So this is the law here. I'm going through the laws together, and then we'll sit together to look at worksheets. So that's the whole idea. Let's look at the whole that just I showed you this slide in the PowerPoint. Please print this one out and make it handy to you, because you'll not have time to look everywhere. Where is the formula I have to use? So you have to have all those formulas handy whenever it comes to calculation. So don't waste your time looking for from one page to other page for the right formula. Keep them handy, and then you can just follow the track on what's given, what's in the problem, what's given, what's asked. So you can tell what formula you have to use. So I'll take this one out, and then the last one here is it's not coming inside the ACS exam or elsewhere, but at least we know something called colligative. At least the definition might come colligative properties of the solution or solutions. So those properties here, those are physical properties. That really depend on the amount of the solute itself, the amount of physical properties of the solution that depend on the amount of the solute. Okay, guys. So one of those here is called the freezing point. Freezing point is one of the example here. One of the example here is freezing point of a solution. This is a collective property which will depend on the amount of the solute. I have a snow, okay. I want to at least to minimize the effect of it or reduce the amount of it. So I will add two items. I will add what do you add if you have snow? You add two items, sand and salt, correct? Sand has nothing to do with the collective properties. Sand has to do with the friction with your tires of your car. I mean, the tire of your car will have more friction, so it can't stop. But the solute is your salt, and the solvent is the ice, the snow itself. So then the more it depends on the amount. The more you add of your salt, the snow will melt quickly, correct? You affect the melting point of this snow, correct? So that's what it says. And there is a formula that's there, but I will not bring it. If I bring it, just let me know, because that will not come. But at least you know there is a formula. This formula will tell you delta T, that's the freezing point of the solution. This is change in freezing point of the solution will be T solvent, temperature of the solvent, minus temperature of the solution, um, okay, so equal I, molality, and K. So I is the charge of the particles of the solute. Okay, so this is, I think it says the formula is at the end of the whole thing here. Just let me show you. Here it is. It's yeah, the pure solvent and the solution. If you look at this is the formula there. So yeah, so it is. Take this one out. Okay, so this is not the solvent, but it has to be said the pure solvent. Yeah. So that's nothing inside. Pure solvent, not only the solvent, but pure solvent. Okay, guys. So the I is the charge, correct? When I put salt in snow, snow is H2O, correct? Just a solid. Sodium here you have Na goes when it's dissolving in H2O will be Na plus ions, correct? And the Cl minus will be plus Cl minus. Okay, so that's the charge. Will give you the charge of this of the solute itself, charge of the particles or ion charges. Calcium will be 2 plus, so it will be 2. So the charge here in this case is 1. Both of them is 1. So 1. M is molality. And this called here, delta T called freezing point depression. Freezing point depression. I don't like the word depression. Depression is it has from geology different, from environment different, from human different meaning of depression. But I like to use a decrease. Freezing point decrease, much better than the depression. Decrease. Because if you have a storm or something and the wind is coming very, very, very harsh on hitting the ground, so it creates depression. So the word depression has two universal meanings. Whatever is in the context, you can do. But decrease means you are lowering the freezing point. So, and the best one is lowering of the freezing point will depend on the charge of the ion of the solute, molality, mole per kilogram of the solvent. Your solvent is snow. That's your solvent here, and the salt here. The salt we put. That's our solute. Okay, and K is called molal because the M here, molal freezing point because it's coming with the freezing point, molar freezing point constant. And it has a name called Van Hoff constant, but don't worry about it. that's the last thing about the idea. The idea is the the more I use salt, okay, as in my solvent snow, the lower will be the freezing point. So I can melt the snow faster, and the freezing point will be lower. Right, guys? So it is this is the formula. So as I said, this will not come because I doubt that we have it in our ACS or in but since Timberlake is bringing it, I said I'll bring it here. So can I take this one out or you need it? You need it? Need it? Take a picture of it. So I'm taking this one out now, and then I'll just go for the formula here. That's what it says here. That's what it says here. Okay, guys, that's what it says here. And as I said, the main thing is if I want to lower a freezing point of a solution, I will add a solute to it as impurities. Like this solute has to be dissolved in this solution, this solvent, so to make a solution. So snow is lowered its freezing point by adding salt to it. The more salt you add, the, the more it's affecting the molarity is affecting the freezing point. Okay, guys, the more lowering, the more decrease in the freezing point you'll get. So, okay, guys, and the last thing here in this is called now, because we have plenty of time, we have to go and review some worksheets about the calculations. But I'm just going through all the formulas first, but you have to bring this one out for the next quiz. All the formulas, make them handy to you. So the last topic called is dialysis. Well, dialysis, you heard about kidney dialysis, correct? So what's happened is in dialysis we have just to give you this is a membrane, semi-membrane. We had them as a plastic bag, special plastic bag with the small holes, like a sponge, small holes. Those holes will allow small ions to get out, small molecules, can go through, correct? What's left inside is larger molecules kept in, large molecules are kept inside this semi-membrane or sponge, or called a filter. Okay, so they are kept inside, and we are moving this one out. The small ions, small molecules, they can go through. H2O, if we have H2O, H2O can go in, go out. Okay, but if we have larger molecules or objects, they will be trapped inside this semi-membrane. And this is the same idea with the kidney. So the kidney stone is produced, and then what's happened is the blood of the patient will be go through the filters through something like this. It's not like this. Just that's in the lab. That's a bag in the lab. We did this one in the past, but they took it out. They said this will be redundant because the biology A and P, I think, are doing the similar experiment. They said, well, we'll not let them do the chemistry. Will be too, we are repeating ourselves in both areas. So, but yeah, this is a kidney dialysis, meaning dialysis we are allowing small particles, molecules to go through semi-membrane bag or filter, going through, while larger, which is this kidney stones, are kept inside this filter. And this is by taking the blood of the patient, going through those filters, those machines, and then the clean blood will be pumped back in, while the filter is filled with a lot of small tiny stones, larger stones, whatever, larger molecules. So you have to cleanse the blood, and you will see there are some, I don't know, depend on the patient, him or herself, they might take this kidney dialysis a couple of days in a week, not only once a month. No, they take it a couple of days in a week. So it depends on the situation, how bad this really is, because the kidney cannot be kept like this. The kidney is the filter of all the fluids inside the body. So without kidney, a person can die. Without the manufacturer factory, what is the factory in our body is really producing a lot of stuff. We cannot live without it. It's producing most of the stuff, all the hormones, all the acid, hydrochloric, everything you can imagine is produced by this organ. What's the name of it? Somebody will tell me? Somebody going for nursing, pre-med, dental hygiene? Correct. Say it loud. Correct. Did you hear it? Okay. Liver, yeah. That produces everything. Hormones, every type of hormone, digestion hormones, I won't say it's sexual hormones, anything hormones, it is produced in the liver. Okay, all those type of stuff. Insulin, controlling the sugar. All this is we call it liver is the factory, is a manufacturing factory of of our human, or not human, of the animal body. So, and this is and the other not factory, but the kidney does produce small, tiny amount of stuff, but very, very limited. But the main thing is a filter. You know the filter, when you filter your tap water, the filter machine, that's the same thing with the kidney. That's what the kidney does. It's filter the whole waste, the whole unwanted fluid inside the body out. I mean, some of it will go as a sweat outside, correct? But that's small, tiny. But the majority of the unwanted fluid inside the body, when it stays like this unwanted fluid, you get blood poisoning, you'll die. You cannot survive without kidneys. Okay? So let me give you the picture here so we know now what dialysis is the going through or diffusion of small tiny molecules or particles through a semi-membrane bag or filter and leaving back all the larger molecules or particles. So can I take this one out? Let's look at the picture and I will give you. Somebody will tell me what the stone, the kidney stone is made of what? No? A little bit? Well, that's the misleading thing about Popeye. It's spinach and it's all this muscle pop up. The Popeye cartoon. That's misleading because most of those green stuff here, veggies, they have oxalate in them, and oxalate, and our body has calcium from the bones, correct? So calcium oxalate is the major component among what's this calcium oxalate. This is the major component of a kidney stone. It's called calcium oxalate. And then you ask yourself, why it's coming? It depends on the metabolism of each animal. Each human is an animal too. So it depends on the metabolism of each animal, of each or human or each whatever. So some people, they will eat spinach like Popeye, will not be affected at all. So they will get even the muscle pumped up. But anyway, don't believe that. So anyway, this is calcium from the oxalate will come from where? The oxalate will come from the veggies, not from the meat or fish or something or fruit. Will come mostly from the veggies. Veggies, they have oxalate in large amount, and one of them is spinach. One of them is spinach. So, well, the calcium is our blood has a calcium inside. We have plenty of calcium ions. When you combine them, you will reduce. We have calcium. I can show you in the lab. The stone is looking like this, and it's very hard. It's not soluble in H2O. So sharp edges. And even if you take one of the crystals and put, you use a small tiny knife. You are cutting your finger with it. Very sharp edges. When solidify, very not the powdery one, but I mean the real solid rocky oxalate. So this is, we call it kidney stone here, kidney stone here. So let me show you a picture of the dialysis and the kidney stone. So if we have time, I don't. If we have time, I can go and look at those. I think in the past I saw the students how they look like. Not the powdery one, calcium oxalate, but they are not soluble except in concentrated acids. They're not soluble in H2O or something. And when they trapped inside this kidney, it cuts like small tiny knives, the kidney. So the person it has to be immediately seen by a doctor, so it has to be removed. So can I take this one out? So this chapter 7 is done, but now we have to go to look. Cool yourself down, cool yourself down. We are done with the topic, but we are not done with the calculations. Correct? We have to go to calculate. But before the calculation, I would like to show you you have to get the sense how this dialysis looks like. It is in the PowerPoint. I think you have one here, so you can see this one here. Everybody can see it? Maybe we'll get bigger picture here. Kidney. Okay, dialysis. Then we're looking for images. Yeah, see here, that's what's up. Maybe one has a filter, so I can show you. Maybe this one here has a filter. Hemolysis, whatever. But this is the machine here. This hemodialysis. This dialysis. So the blood is going in. That's the one has particles inside. You said not a good blood, but not a good blood. The one coming out from the machine, that's the good one. That's after with the green arrow. Can you see it? Maybe I have to snip it and make it bigger so you can see it. So this is, copy this one here. You can see now. So that's the green one, the green arrow. That's the good one after filtration. After not really filtration, we cannot see it. That's a similar membrane. Yeah, we can say filtration, and there inside the filters, they are keeping the larger molecules, which is kidney stones, and all larger molecules out, pumping back in the blood with the small particles, such H2O, sodium chloride. Any small particle go through, but the big ones, they will be trapped inside. Okay, guys, that's the whole idea here. Okay, and the blood filter, you see those here? This side here, let me just show you here. I'm sure that's one time in your life, one of your family member or friends has problem with kidney. I had some couple of friends, they have problems with this. They were at the mountains and they start drinking. They're running out of tap water. They took some tap water from the pond and a lot of junky stuff. They trapped inside their kidney a lot of a lot, not to kidney stone, a lot of other stuff, so larger molecules. So this is the filter here. That's the semi-membrane is here. Are you following me here? So going in, going the filter, the blue one is going from the arm of the patient here, the blue one. That's the one is it has to be clean, cleansed, you know, purified. So go through this membrane, going out clean, see, and then go out this system here, all the system here, out, 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 going back to the green one. And depending on the situation, some people I saw, they take like three days a week, three times a week, some of them one time, sometime one a month, but depending on the situation of the disease itself. Any question about kidney dialysis? Any question? Any question? So now, let me scare you a little bit with the kidney stone. You will be surprised. That's a small, tiny piece, like here, like this one. Some of them even larger. So you put them in your hand. It's very, very scary. Those real stone and sharp edges. I wish we have time. I can look at them. They have rearranged our lab, so I can show you the how they look like. So let's kid now. So take this one here and say instead of dialysis, write stone or stones. So different stone. One of the biggest one here it is. See those two here. Let me see. Can you see the sharp edges here? Maybe I will. Can you see the sharp edges? Can you see them? I went to the lab and get the students have the feeling of this. It's really like a small, tiny, blade or a scissor or a small, tiny knife. It's very, very sharp. It can pinch through your skin. Can you see it? And that has to be by laser taken out, or sometimes, all times by surgery, manual surgery. They take it manual surgery, but now it's very fancy. They can be taken small, so they can be trapped easily, and they can be taken, or just when it's very, very tiny, it can be get rid of. So it will be just taken by a laser, the small pieces. So it's another one. This is a picture of that. This is another picture here. Here, this is another picture. I can show you how the edge is like a glass, like a, broken glass. Remember the broken glass? How they look like this? They have like edges of a glass. They can cut, and they can go in the neck of the kidney, and then cause all this bleeding because it can cut all the tissues. So let me show you another picture of where they settle down because of their masses. They are heavy, so they can sit in the kidney. I think can you see with me a picture where they settle down? I think you can see where they settle down. And the problem with them, if somebody got this kidney stone large, that person cannot sit, cannot go right, left, cannot move. Anything doing like this, somebody is stabbing him or her from the back, like with the knife. That's what my friend is telling me. You cannot move left or right or go up. You just like this. Anytime you move, a lot of pain. Somebody like punching through with a small tiny dagger or knife from the back. So sharp. So let me show you where they can end it. I think they end in the canal of the kidney. Where is it? Maybe here. Yeah, so you can see they got here in this canal here before we get all the waste out. So they come here and they just cut all the pieces, the tissues, like small tiny glass, broken glass, and it's used to cut somebody's hand or finger with it. So that's yeah. If you are interested, you can look into that in some details. Okay, guys, it's It's not a joke. It's not really a joke. It's very painful disease. So now I think we covered all the stuff. Now let's go for the serious thing here. Okay, this chapter is done. Now we'll go for with the concentration, mass to volume percentage. Let's do this. Okay, guys. Increase it a little bit so you can see it with me. So choose first. Let me make it here. Those are 4, 5, 4. Choose one of the 4, and then we'll do calculation. See what we got. I want to have this is first thing here. We are looking for. Spend some time on those calculations. Very important. Mass over volume percent, which is mass of the solute, volume of the solvent, or volume of the solution, multiplied by 100%. So this is the major one, correct? The major formula. Can I make 2 sub-formulas of this? Can I make 2 sub-formulas of this, yes or no? Yes, correct? Which one? So this is mass over the volume percentage. That's the major one, correct? I can make sub-formulas for, I can determine the mass of the solute, or I can determine volume of the solution. This is mass of the solute here, or the volume of the solution. Okay? So, and one of them is, I will do 3. That's me. So we can use one of the sub-formulas. And you can take those formulas, you have them there. So let's choose, can I take this one out? Take it out? Okay. We'll do the calculation. So which one you like? Mine is 3. I want to take 3. There's no what I said. There's no answers. We have to come up with our answer. The answer is given you in bold, but does not show you how to do it, correct? Does not show you how to do it. So you have the answer in bold, parentheses bold, but does not show you. So I will take 3. So which one you like? And you take maybe 2 of those, or one, and then we'll go mass to mass, mass to volume. One of those for you, one for me. I'll take 3. So which one you like? 1 to 6. They have 1 to 6. Let me lower it maybe. Sorry about this. 1 to 6. So which one? Which one, guys? Come on. Which one? 5. You see, the sub formulas are, I put them inside alcohol. The sub formulas are given to you in 3 and 4. So this is the sub formula. One I can get the volume, the other one I get the mass. So I will take 3, and then 4 is redundant, but that's another sub formula. Let's take from 1 and 2 and 5 and 6. So 3 and 4 is similar. I can set them up, and then you can calculate them. So you have 1, 2, 5, and 6. Come on, guys. It's not Monday. Which one you like? Which one? 1, 2, 5, 6. Select one. Which one? 2? Who said 2? 2? Okay, let's take 2. I'll take snipping tool. I'll take the 2 here. Okay, so. And we have to watch what? Somebody will tell me what we have to watch. This is the other one. With this calculation, what do we have to watch? The formula, yeah, we know the formula, but we have to watch something. Somebody will tell me. Don't let me down. Which one? Well, you forgot about this. Very important. It will come until the final exam. Which one? Sig figs. Correct. Correct. Perfect. So that's an evidence. Today is Wednesday. That's good. Today is Wednesday, not Monday. So now it says what is the concentration mass over the volume? That's the concentration here. Mass of the volume of 67 grams. There's no decimal, but since there are no decimal, I will put the decimal here. There's two sig figs. They should put decimal. So, but here decimal. Here there is a decimal. Two sig figs. So our answer has to have to are dissolved in 1.2 liter of solution. Correct? So mass of a volume percentage, it has a unit. You have to watch. The unit is gram per ml percentage. That's the unit. But we have liter here. That's a problem. So we have to multiply it by 1,000 to get milliliter, correct? So the mass is 67. So the solution is 67 grams of the solute. I'll put the decimal here. So, and this is 1.2 liter. In 1 liter, I have 1,000 milliliter, correct? Liter cancels out. So this is, and the whole thing here multiplied by 100%. Oops, sorry. What's happened now? Okay. So 100%. So I have 67 point gram, 1.2 multiplied by 1,000, and this is milliliter, and the whole thing by 100%. So is the answer 5-6%? I don't know. Somebody had calculated? Okay, so you force me to calculate? Okay, I don't mind. I don't mind. I don't mind. Here it is. So we have 67 divided by 1.2 divided by 1,000 and then multiplied by 100%. This is 5.583. That's the answer, correct? However, this answer is too many sig figs. I don't know, maybe 15 sig figs. We are not looking for 15, so let me just. So the answer is 5 point, this is there, correct? That's in the top. Well, then I will say I need two sig figs. The bottom, two sig figs at the top. So the answer will be two sig figs, which is 5.6%. So the answer is correct. So this worksheet is really absorbing the sig figs. So that's the number what? Number 2. Let's do number 3. Everybody has this? Everybody has this? Okay, let's do number 3. Taking this one out. Okay, take this one out too. Well, took it as header, but anyway, so don't worry. So let's take number 3. So let's take snipping tool for 3. And we can do 4 if you want to, so we can do 4. So now, we can. Okay, so what's the volume, what is the volume of a 40% solution or contains 670 grams of the solute? Now here we have a problem. What's the problem here? A sig fix, a sig fix. The sig fix is the problem because look guys, this is not good when it comes to the sig fix because that gives confusion when it comes to multiple choices. Now this is according whatever they have. This is one sig fix, correct? And this is what? Two or one sig fix? One sig fix. And the answer is how much? It's three sig fix. And that's not correct. Yeah, so I will say this is 40 and then put a decimal, make it two sig fix. I can make it one, that's fine. I mean, but at least you have to have a decimal somewhere to, this is 70 decimal, I mean, gram two sig fix. So it's give you the formula, mass over volume percentage is mass of the solute, volume of solution multiplied by 100. So this one here is 40, correct? Or here it is. Let's see what's given, what's asked. So 40 here, 2 sig fix equal to. They need, what's the volume? The volume of the solution, I don't know. This is X. And this is 100. And the mass of the solution is 70 grams. I added the decimal. And this is so how I can get X? How can I get X? Cross multiply, correct? So cross multiply the X with the 40 here. So I have 40 and then X equal to and equal to 70 gram and 100. So divide both sides by 40, correct? So this cancels out. X is the volume of the solution will be 70 gram, correct? And here the unit of the M volume here, the unit is gram per ml. So multiply by 100 divided by 40, and the units here, look at the units here, gram per ml. Gram cancels out, the ml will come up. So 70 multiplied by 100 divided by 40. I have two sig fix. So what's the answer? Somebody has it? Or you want me to do it for you, correct? Well, then let's do it together. We'll do it together. So we have how much? 175? 175. Oh, the answer is here. So sorry about this. Sorry about this. Okay. So the answer is it says 175 ml. Is this answer correct? Correct or not correct? It's not correct. How in the world you get three sig fix while you have only two sig fix here and two fix here? How in the world you get three sig fix out of two? The answer is not correct. So introduce what scientific notation. So I have to make out of 175 ml two sig fix. Out of the three, two sig fix. I can introduce whatever the multiple choices is, introduce significant figure there. I will say I can move the decimal here, 2 here. I can introduce the decimal here, or here, or here, whatever I like. Correct? Whatever I like. So which one you like? Before the 1, or after the 1, or after the 7? Which one? After the 1? Okay, so then I'm moving it after the 1. This is two sig fix. So 175 ml. So I move it what? 2 to the left. And before we add ml, 1.75, 10 power. To the left means positive. And 2 digits, correct? 2 digits divided by 2. So I have to have, this is still 3. So I have to have this one here up, correct? This is 1.8, 10 plus 2 ml. Okay, guys? That's the correct answer. That's the correct answer. Or I can put it 1.8, 10 power plus 3 ml. Okay? Or 18, I put it just 1, 10 power plus 1 ml. All this one, power 1, power plus 3, power plus 2 ml. Those are the same answers. It depends on how many digits you are moving your decimal to the left. Okay, guys? Now, I'll give you 1 minute to do number 4. And I'm not calculating. I want you to, let's feel it that today is Wednesday, correct? Everybody feels this way? No? Come on, you are letting me down. We have a lab, 3 hours or more. So we have still long day. So let's take this one out here. And take number 4, correct? Number 4. Okay, let's take number 4. Okay, let me take snippet. Number 4. So the first one we did what? The mass over the volume. Then we did the volume. Now we do the mass. 2 subformulas. So copy and paste. So again, is the answer is correct? Correct or not correct? No, it's not correct. Why? Because yes, you get that now. You get the idea. That's correct. That's correct. This is one sig fix. Correct? This is one sig fix. Looks like it's correct this time. And this is one sig fix. Well, I'll say correct this time because by chance, but it did not really follow the sig fix. But all those answers is one sig fix. Well, no decimal, no nothing. But here is the amount of the solute. We have mass over the volume equal mass over volume, mass of the solute, volume of solution multiplied by 100. So what's this unknown here? This is given to us. That's the 20, correct? And what's the amount of the mass? We don't know. X, the top. Volume is 0.5 liter multiplied by 100. And liter, we know we have to get 1,000 milliliter over 1 liter. Liter cancels out. Because this has to be ml, correct? The volume in ml and the mass in grams. So then cross multiply. So you have 20 equal x equal 0.5 multiplied by 1,000 multiplied by 100. Solve for x. Correct? Cross multiply 20 multiplied by 0.5 thousand equal to x 100. Solve for x, divide both sides by 100, both sides by 100, 2 zeros out. 20 multiplied by 0.5 is 10. 10 multiplied by 10 is, the answer is 100 grams. Okay? Make sense, guys? Make sense? Okay. So let's look at the another Another one. Um, can I take this one out? Everybody has it? Okay. So let's take this one out. And let's take okay, take this one out. And then we had this is mass by volume of volume. The first one is, let's look, let's minimize this so you can see. Um, so this one give you the formula. This is inside iCollege. This one's already inside iCollege. So select one of those. We'll do volume to volume percent, mass to mass percent. And remember that the formula is now you have the mass of the solution. If you remember this, see here, volume of the volume means what? Volume of the solution, which is volume of solute plus volume of the solvent. And here, mass of the solution, mass of the solute plus mass of the solvent. Okay, guys. Now, let me take this one out. Everybody has it? So let me take this one here out. And then you tell me which one you like to go through. We have up to 5, 6, 7, 8, 9, wow, 10. We have 10 ones. I can't really. So even with this decreasing, I cannot get the idea. But anyway, so you can look at. So I can tell you just, let's take which one you like now. Quick. This is mass to mass from 1 to 3. I think mass 2 is volume to volume. First one, mass to mass. 3 is mass to mass. Which you like? Which you like? From 1 to 4 first. Which one? Any preference? Any preference? Did we take number 2 before? Yeah. Not superstitious about numbers, but I thought we have it. So now look at this. This is, what is the percent by volume? Percent by volume is both volume of the solute divided by volume of the solute plus volume of the solvent multiplied by 100. And this, all this here is said to be equal volume of the solution. Volume of the solution. So now number 2 we have making benzene, which is a solvent, which is solute. The most abundant one will be solvent, correct? Which is the 20 mLs. Toluene is our solvent because large amount of it present. And the 25, the smallest amount, that's our solute, which is benzene. So the solute is 20 ml, correct? And volume of the solute is 20 plus 80 ml, and the whole thing multiplied by 100. Okay, guys? So this one here will be 20 over 100 ml, ml, and multiplied by 100. Correct? And the answer is 20, correct? The answer is what? 20. And the units ml, 20 ml over 20 ml over ml. So the unit will be, the answer is 20, correct? This is, yeah, they did not look at the sig fix, but I'll put this with the decimal here, decimal. So 20 ml durch ml. This is solute, which is benzene, and ml is solution, both solute and solvent. Okay, guys. So, can I take this one out? Let's take mass over mass. Can I take this one out? And let's do mass over mass, which is in this case what? Here it is. Mass over mass is, here it is, guys. Mass over mass percent will equal mass of the solute, mass of solute plus mass of the solvent. And the whole thing here is multiplied by 100. Okay, multiply by 100 here it is. Okay, so that's the definition. Now, it will give us 25. Ammonium is small amount, 35. 250, the largest one. So it will be 35 the solute, 35 divided by 35 plus 250. All this mass, gram and this gram. And the whole thing here is multiplied by 100%. Okay, guys? So 35 divided by 70. So 35 divided by 70 multiplied by 100. Correct? So that will be 50 percent. So since we don't know what's the answer is, the answer both sides 2 sig fixed 35 to 250. So we can put the decimal here somewhere. So those decimals here. Okay, guys. So I think this one will cover all the volume to volume, mass to mass, and mass over volume. Let's do molarity here. Let's do what? Molarity. So let me see. Can I take this one out? Let's do molarity here. Okay, let's do molarity here. Okay, molarity will look, that's the folder you have here. We have dilution and molarity. Those are very important. Diffusion. Well, there is molarity. Yeah, here they are. Molarity, they are here. Okay, molarity calculations. Pick up one or two of those, one or two, which one you like. And everybody knows molarity is mole per liter, correct? So this is straight. I will take one from 1 to 7, 1 to 6, or 1 to 5, because that's direct. Mole, they give you the mole, they give you the liters. But then we'll take 1 from 6, 7, 8, 1. So let me do the, it is. We'll take one of this, one of this. So which one you like? The first one is easy because this is the molarity here, capital M, is mole per liter. Mole of the solute, mole of solute, and liter of solution. Okay, guys, so which one you like? Straightforward, correct? Which one? Come on, guys, don't let me down. Which one? Oh, you are wasting my time here. I don't know. That sounds like Monday. Number 4. What we have to watch for number 4? Tricky. It's very tricky. What we have to watch for number 4? What's our definition is? Mole per what? Liter. What we have here? That's a problem. This is a problem. So we have to convert the milliliter into liters. That's the first thing. So 65 ml. I have to go 1 liter here. And ml here, remember the correct ml here. The m is 10 minus what? 3, small m. So what should I put in front of it? 10 what? Plus 3, correct? The opposite of it. So ml cancels out, ml cancels out. And I have 6.5. Take this one up, will be 6, 10 minus 3 liter. So 65, 10 power minus 3 liters. So then you take the molarity will be 0.75 mole per 65, 10 minus 3 liter, correct? And just do the whole calculation yourself. That's not really difficult, correct? Everybody agrees? Everybody agrees, or you want me to solve it for you? It's good. That's very simple math. And as a matter of fact, here it is. You can simplify the whole thing. 0.75 mole. And then this is 10 minus 3. This will be 0.065 liter. You just divide 0.75 by 0.065. You get mole per liter. So that will be it. Then we'll select from 6 to 8. From 6 to 8. So everybody has it? Everybody has it? No? Yes? Yes? No? You can take snapshot of it. Okay, guys? I want to finish the chapter. We have 5 minutes to finish this chapter. Then, so next week, chapter 8. So 6 to 7 or 8, which one? Which one, guys? 8. Okay. So we have 12 grams of hydrochloric acid and 25 milliliter. That's good. I like this one. Challenging. We have to do what? Because our definition is mole per liter. So we have an issue with the mole. We have issue with the liter. So first of all, we have to get this 25 ml. By now, you know how to do it. Correct? I showed you. Which is really is 0.025 liter. That's just done. How about 1.2 grams of HCl? HCl has the formula HCl. H and Cl, hydrochloric acid. And I need gram, but I need more. What should I do? I use what? Molar mass, correct? molar mass of HCl equal to one hydrogen, one chlorine. Is one hydrogen atomic mass of hydrogen is point oh is I put just 1.08, but I put just 1.0 gram per mole. One plus the chlorine is 35.5 gram per mole. Add them up, it will be 36. So that will be 36, correct? So the molar mass of HCl, molar mass of HCl is 36.5 gram per mole, correct? So if I divide the grams, 1.2, take this 1.2 here, 1.2 gram divided by the molar mass, 36 for HCl, 36.5 gram per mole. So the gram cancels with the gram. I have 1.2 divided by 36.5. This one here, the mole will come up and the unit is in mole. 1.2, that's the mole. And the liter is here. So 1.2, let me see. 1.2 divided by 36.5, that will be 0.038. So the moles here, number 4, correct? You have number 4 or no, number 8. So we have number 8 is, we have said how many we have? The calculator came out to be 0.0328 or 0.03. So 0.0328. This is mole, and the liter is 0.025 liter, correct? You divide those together, we have 0.08. Yeah, 287. So 287. So this one here might be, we can round it to 9 here. So 0.0329 moles, because we took the amount of the 1.2 of the HCl, we divided by its molar mass to get number of moles. We convert the milliliter of HCl into liters. Came out to be this. And this came out to be the moles here somewhere. This one is divided by 1.2 divided by molar mass, 36.5. And then when you divide those, you get what? You get the mole per liter, the molarity. Okay, guys. I have one more about. We'll talk about the dilution, and then we'll stop here, and then we'll come back, finish the last tab, which is the dilution. So here it is. Just to show you here. Every time you take 1 minute, just let me take just a small amount of your time. Every time you take 1 minute. So if I calculate, you are owed at least 2-3 minutes, correct? You are owed. So, but anyway, so we'll be looking at this, the molarity and all this here. That's in iCollege, everything in iCollege. We'll look at the dilution and come back. Okay, guys, and that will be it. Chapter 7 is done. Will be chapter 8. Thank you very much. So, it's 46. So I really took one minute.